right, let's continue on with sample problem N on page 249. I've written out basically our given, which is the empirical formula P2O5, and the molar mass, which is 283.9 grams per mole. Okay, very good. Let's move on. So let's look at the plan that the book gives us. It says X times the empirical formula equals the molecular mass. If you don't remember well, let me put a couple numbers in here. From our example, in the past we said, let's say if X is 2 and our empirical formula is BH3 for diborane, then our molecular formula is going to be B2H6 for the real molecular formula. We also know in our plan that X equals the molecular formula mass divided by the empirical formula mass. What is the molecular formula mass again? That is the weight in AMU for the molecule itself, and the empirical formula mass is the weight in AMU of the empirical formula. So it says we're going to compute molecular formula mass is numerically equal to the molar mass. Thus, changing the gram to mole unit of the compound's molar mass to AMU yields the compound's molecular mass. So basically, hey, it's saying, look, we've got 283.89 grams per mole. That's just the same as saying 283.9 atomic mass units for one molecule. Okay, so then it says, the empirical formula mass is found by adding the masses of each of the atoms indicated in the empirical formula. So it's the mass of phosphorus is 30.97 AMU. Found that in the back of the book. The mass of oxygen is 16.00 AMU from the back of the book. Therefore, the empirical formula mass is P2, 2 times 30.97, plus 5 times 16 is equal to 141.94 grams AMU. Now this is important. This is a different number than what we were given in the beginning. In the beginning we were given the molecule's molar mass. The molar mass of the molecule is 283.9. But the molar mass of the empirical formula is 141.94. So basically what you do is you divide the empirical formula mass, that's that one right here, the empirical formula mass, the experimental formula mass, by the empirical formula mass to give the value of X. Same as here. So X equals molecular formula mass. What was our molecular formula mass? That's from our given 283.89. And what's our empirical formula mass? Well, we found that by multiplying the weights of phosphorus and oxygens together to find 141.94. And you can see that's exactly what they did down here. And that gives you X, which is 2.0001. And remember, such a little difference with the 1 means it's 2. The compound's molecular formula, therefore, is P4O10. Why? Because 2 times P2O5 is P4O10. All right, class, good job. I know I kind of went quickly through that. I think, though, that if you choose to do the practice problems 1 and 2, and be sure to do section review questions 1 through 4, you'll definitely be ready for our quiz. These look like great quiz questions. All right, this is Mr. Worley signing off, but before I do, let me review with you what our objectives was: to define an empirical formula and explain how the term applies to ionic and molecular compounds. Well, an empirical formula was the smallest whole number ratio of atoms in a compound. How does it apply to ionic and molecular compounds? Usually, the ionic formula unit is the same as the empirical mass. With molecular compounds, however, it's often different. Just like diborane's empirical formula, BH2, and its molecular formula, B2H6, are different. Next one, determine an empirical formula from either the percentage or a mass composition. Well, that's exactly what we did in sample problem M, where we determined, now let's go back to the screen, where we determined the we determined the empirical formula given the mass of the sample. And we did that in sample problems L when we were given the percentage composition, 32.38, 22.65, and 44.99. And what was our other objectives? Explain the relationship between the empirical formula and the molecular formula of a given compound. The relationship between the molecular formula and the empirical formula basically is the equation represented on page, just a moment, what page was that? Page 248. Here's the relationship. The relationship between empirical formula and molecular formula is you have to multiply the empirical formula by some number, x, a whole number, to get the molecular formula. Remember in our example we had BH2 for diborane, and we multiplied it times x, which happened to be 2, to get B2H6. And our final objective was to determine a molecular formula from an empirical formula, and that's what we did in sample problem N. How did we do that? We basically, let's check it out. We basically used the molecular molar mass. We turned the molecular molar mass into atomic formula mass, which is just basically rewriting it and calling it AMU. And then we took that and we divided it by the empirical formula mass, which happened to be 100 and what was it? 140 something or other, whatever it was, and we got a number 2. That was our x, and we multiplied 2 times P2O5, and that gave us P4010. All right, class, thank you very much. I love you. God loves you too, and I can't wait to see you. Be ready for quizaroo. This is Mr. Worley signing off.